Question number 3. If a in bracket y plus z is equal to b in bracket z plus x is equal to c in bracket x plus y, and out of a, b and c no two of them are equal, means no any two of them means a, b, c are equal, then show that y minus z upon a in bracket b minus c is equal to z minus x upon b bracket c minus a is equal to x minus y upon c bracket a minus b. Now we have given condition, out of a, b, c no two of them are equal. Therefore a minus b, b minus c and c minus a are not equal to 0. These are not equal to 0. Did you understand? Therefore, first of all, I will write this given. See here, a in bracket y plus z is equal to b in bracket z plus x is equal to c in bracket x plus y. Now dividing all these three terms by ABC, dividing all three terms by ABC. Therefore, say this, a in bracket y plus z upon ABC, a cancel, is equal to, say this, b in bracket z plus x upon a, b, c, bb cancel, is equal to c in bracket x plus y upon abc, cc cancel. Now therefore let y plus z upon bc, y plus z upon what is denominator bc is equal to, say this, z plus x upon ac is equal to x plus y upon ab is equal to k. Now I am not giving here number, I have put there. We take this, here we write x plus y upon AB. AB is equal to z plus x upon AC is equal to k. Now by theorem on equal ratios, we write this way, x plus y minus z plus x upon, because here we want minus sign, no, so we write this way, then AB minus AC is equal to k. Okay, now here because of this minus sign, internal sign changes, therefore x plus y minus sign changes, minus z minus x upon, here a common, so what is left, b minus c is equal to our k. Okay, here plus x minus x cancel, therefore y minus z upon A in bracket B minus C. Okay, this is our is equal to K equation number 1. Did you understand? Similarly, B, okay, see here. Now we want B in bracket C minus A. B in bracket B, see here. B in bracket C minus A. See this. B means we take y plus z upon BC is equal to x plus y upon AB. See here, B common, no, series is equal to K. By theorem on equal ratios, by theorem on equal ratios, y plus z minus in bracket x plus y upon BC minus here AB is equal to K. Did you understand? Therefore, y plus z minus x minus y upon B common, B in bracket C minus A is equal to K. Y cancel. Therefore, z minus x upon B in bracket C minus A is equal to K. This is equation number 2. Similarly, we take or write. Say this. We want C in bracket A minus B. So we want AC first. Means Z plus X upon AC is equal to, see this, BC or CB. BC or CB is equal to Y plus Z upon BC is equal to K. Now, by theorem on equal ratios, by theorem on equal ratios, see here, Z, we want here minus, we want here minus, here also minus, Z plus X minus, because we want minus. Here in this, show that or to prove, bracket y plus z upon, same here also subtraction, AC minus BC is equal to K. Okay, now I erase this series. Now here, therefore, Z plus X minus Y minus Z upon, here C common, C common. So what is left? A minus B is equal to K. Did you understand this? Now here Z plus minus Z cancel. Therefore X minus Y upon C in bracket A minus B is equal to K. Equation number 3. From equation 1, 2 and 3, right sides or right hand sides are same, means K or equal, K, K and K. In equations 1, 2, 3, right hand sides are equal, means K, K, K. Therefore, left hand sides are also equal. Left hand sides are also equal. Therefore, what is here? First, Y minus Z upon A in bracket B minus C is equal to, second, Z minus X upon B bracket C minus A, and third our x minus y upon C in bracket A minus B. This is our to prove or show that series, same to same.